Good. Okay. My name is Thorsten Lohmar. I'm working for Ericsson, and I'm also rapporteur for this 3PP study, media production over 5G NPN. Of course, here first, an NPN can be a standalone NPN, meaning kind of a dedicated on-site network, or it can be a PNI NPN, meaning it is something integrated into an existing wide area network. And here, the study is not kind of focusing on one or the other. So in principle, both is in scope. The thing here is basically there should be some sort of collaboration in place between operator and the media producers. So that is the key thing. And it's not about the type of network setup. Right. The other thing is, of course, the aim of this 3PP study is about how does media producers use the network. So from an Ericsson perspective, it's more the topic about, let's say, understanding how media producers are intended to leverage 3PP technology. Of course, we have seen many trials around sending uplink video and these type of things. It's of course likely challenging, but at least I realize this is not everything. Many media producers come from a more CFDM type of background, kind of working with cameras in a production space. Some others come more from a cellular bonding perspective into this topic. And what I learned is kind of this topic is much more about, would say, just replacing the wireless technology. It's also about how to operate with the system, what are the workflows, and so on. So my prime interest here would be to learn more about, say, the existing workflows. Is it the right way of kind of modeling or using what is 3PP providing? Also, kind of how is media production kind of evolving when moving into IP, when kind of moving more of IP technology. So I guess it's also a bit of a journey. Right. So now a bit on the study. The study objective, it has been started quite some time. It is about, I would say, identifying based on the existing SA1 work in 22.8.7 relevant media production use cases for professional, semi-professional type of cases, production and contribution. It is about identifying different type of media and control type of flows. So what things is actually happening. It is about identifying relevant cost requirements. Of course, not only costs, it's also about, let's say, network slicing and other type of system features. And of course, non-public networks come in, although there's, of course, also use cases where not a fully non-public network is kind of used. So here, at least, we should take this non-public network as a bit wider as the pure 3PP definition. Then it's about identifying existing media production protocols and codecs. So I think today it's a bit in this space. So what are the typical protocols or intended protocols to use? And even more important, when people think about camera configuration and control, what is acceptable to work with? What do people want to see when, would say, more an IP-based system become in place, more automation can be used, and so on. And the overall intention is, of course, to identify whether there is a true need to produce normative specifications. So it's really about identifying standards needs and standards gaps. So that it's becoming clear whether 3PP should do something more. At this stage, I have the impression kind of it's more about guidelines, but this study is still in the go. From a timing perspective, the study has been started in March of this year. We are approaching an end. In principle, the study is supposed to be finalized in February next year. This is still the physical dates. It should be the electronic dates. Of course, since it's a study, it can be prolonged a bit. However, it should not be a never-ending type of study, so we should come to an end. I think the TR26805 contains lots of good content. So it contains a very comprehensive overview of existing media protocols and workflows. Of course, there can be always more. It differentiates between kind of production use cases, meaning locally on site, and contribution use cases, meaning um, um, carrying the content between the production site and the studio. There's a subdivision of different production tiers, primarily based on the involved planning and the involved budget. There's of course sometimes a bit of a different need, and of course if you have a very important event, then planning starts earlier and you have a bit more budget available than if it's a bit less one. And of course, there's also the completely spontaneous events like news gathering and so on, where you basically are happy with whatever is available and of course try to get the most out of it. From a protocol perspective, we have identified a range of protocols. Also here, probably there's more. We have started looking into SMPTE 2110. We looked into SRT, RIST, NDI a bit. So I have the impression kind of just purely from the media, from the video and audio transport, there's a good set of standards. When it comes to control, we looked into NMOS. Of course, there is things happening, but at least kind of I start wondering a bit, there should be more. We also worked a bit on audio network and so on. You know, me as an outsider, I should have known that there's audio engineers and video engineers. Yeah, but still, now I kind of understood that there's in production space a typical separation. There's also kind of a good description of relevant production use cases. We have one about the wireless camera workflow. We have one on outside broadcast contribution type of workflow, and of course a bit independent. Is the work with remote and cloud-based production. Because of course, the moment you start using 5G, the step towards kind of remote production or cloud-based production is also not that large anymore, right? Now, from an identification, from an solution space, in the study we have identified a set of key issues or potential key issues. It's still an open list, so it's still kind of possible to add key issues. So far, we have identified utilization of available capacity, media protocols, and specifically using QoS and for traffic separation. I think we should rename this heading more QoS and network slicing for traffic separation. It's more about, say, how should the system offer the needed quality. Then we have a key issue about remote camera configuration and remote control. This is really kind of getting into the topic on, okay, if you have a wireless camera, really, how do you basically set up everything? How do you control everything? It might be sometimes a bit painful to always run to the camera and to do changes and so on. And of course, the cameraman is supposed to focus a bit more on the creative part and not so much on the camera itself as a technology piece. Of course, then we started identifying, would say, different type of bitrate capacity usage scenarios. So one is a bit more from an operational workflow, switching, for instance, between standby and program cameras in order to save capacity. Then, of course, we see lots of solutions which work with dynamic bitrate adaptation, meaning how to react to network conditions, like when capacity is a bit unstable, would say. There can be multiple reasons like fading or just plain congestion, which kind of causing this issue. And then there's one issue about configurable audio channels, which is about, let's say, how to basically bring these workflows of having static pre-allocated channels, audio channels like in SDI or MADI, into a shared system where you don't want to allocate capacity if you basically are not going to use a certain channel and so on. It's a bit more on the interoperability side, I would say. And then, of course, there's one thing more from a system perspective. It's about usage of NPNs. But there it's a bit more also on the onboarding side, how to work with NPNs and these things. Now, a bit on more details, more towards cross and network slices. No, first, it's also a bit off on the need now. I think the study has progressed very well. We have structured the TI, and there's now soon a new version coming out, version 1.0.1, which you might find soon. And now the focus here on this workshop is it would be good to get more input from the community, basically, on different key issues, in particular around camera configuration and control. So here, maybe it's also about on the definition, at least what I've understood from the definition side, remote camera configuration is something what is happening typically before the actual capturing event. And here, my prime concern is about basic IP connectivity configurations. Let's say how to configure the receivers of media flows, how to do codec configurations with respect to bit rates and so on. Because of course, we are likely running compressed video, and people need to basically figure out how much capacity is available, how to allocate the budget for the different cameras and so on. Then maybe there's a bit of a new aspect coming in. It's a bit more on dynamic configurations, for instance, to define a profile for a standby and a program camera, and then kind of doing the workflow during the production event, basically dynamically switch between these profiles so that you kind of, that the available capacity is better shared, or that you can basically get more cameras out of the existing capacity. And then, of course, there's the entire area of camera control, light control, tally, and maybe also pan, tilt, zoom, meaning when you have a bidirectional system, how much do people want to control the camera during the lifetime of the capturing? What does it actually mean for the networking side and so on? You know, this is kind of the most interesting thing for us. So what does it actually mean for the networking? What does it mean for network features like quality of service and network slices? How to actually use it? Yeah. For a bit of a deep dive now into one issue on cross and network slicing. In the TI, we started working with this type of model, and you will kind of in the next session, you will learn a bit more, where does it come from and so on. We have basically started prioritizing a bit the different flows coming out of a single camera. So I call it here media production perspective, meaning from a media production side, there's a certain interest to use an IP network. There's a certain way of configuring and controlling the system. And in order to get a certain good quality out of the system, of course, you may want to separate the different flows in order to ensure that the important flows get the capacity when needed, while the other ones are kind of a bit separate. Of course, today with COFDM type of cameras, this is done kind of one-to-one. You have one camera and one piece of spectrum, and of course, there is no, would say, sharing. It's a very basic way of providing quality of service. But of course, in a bidirectional system or in a shared system, there's other mechanisms to do a similar thing. Then the interesting thing then for the study is to look into the networking perspective. So if media producers want to basically separate out different flows, how does the 5G system basically understand and identifies the traffic flows, which are somehow need to be treated differently? And here, of course, in 3GPP, there is a very extensive set around shallow packet inspection, it's called, meaning to look into different header fields in the IP communication stack, meaning like IP addresses, protocols, and so on. Based on this, basically, traffic flows are separated. That, of course, works fine if you're using, let's say, separated audio and video and these type of things. It gets a bit more complicated if things is multiplexed onto the same pipe. Probably even worse when there's some sort of tunneling mechanism used. Then basically the 5G system can't really separate it out the traffic flows anymore, and it's not really possible to provide flow-based cross, but you can only provide a cross for the entire pipe. So the idea of this study is basically to identify how is the network used, so what type of features are relevant. And again, the idea of this workshop is now to collect more input on, would say, how are media producers using today the system, how they're intending to use the system tomorrow more. So what type of additional features become available the moment the migration towards IP is kind of taking the next steps. So in that sense, it would be good to get input and insights, right? You know, from a research perspective, we are looking into 5G records. I'm also part of 5G records. This is certainly one view on the problem. There might be other views. Here in 5G records, we are working around this architecture where we basically starting separating kind of the traffic flows over the 5G system from the traffic flows inside of the production system. And there the basic thing is basically on 5G, we need to work with compressed video in order to leverage the capacity, while completely different protocols and formats are used in the production environment. So when it's SMPTE 2110, quite often it's completely uncompressed. So that was a prime driver to insert this gateway into the path. And since we have this gateway, and since there is certain pieces optimized from the media orchestration and control functions, we added this media and control gateway, which is on one side controlling the media gateway in order to kind of the mapping kind of from what camera to send to what resources in the media production side. And second, this is again for the study important, how does the orchestration solution interact with the 5G system? So how is the network exposure kind of used, for instance, to set up cross flows and these type of things? I would expect that other people have other views. So in that sense, of course, I'm sharing this because I would also like to understand more what type of alternative solutions are under discussion and so on. Anyway, I started sharing these insights, and now Ivan and David will provide some more details around how this was kind of developed. So from my side, this is basically what I wanted to present from the study.